Hi, my name is Anna Kukleva, and today I'm going to present our work XMIG that was done during my internship at Meta. In this work, we're talking about action recognition. You might all know about datasets like kinetics. These types of videos depict third-person view and mostly collected from the platforms like YouTube. For such videos, it's easy to control the collected distribution and ensure balanced classes. And the most interesting fact that these videos are easily classified with a clip model where action recognition on kinetics achieves about 60% accuracy. On the other side, there is recent interest in egocentric videos. These videos are collected by mounting camera on the person and recording daily life activities, and therefore the distribution of collected classes follows real world and is long-tailed. Due to the distribution shift between pre-training and given data, clip action recognition reaches only about 10% accuracy. As a standard practice, egocentric action consists of two parts, verb and the main interactive object. Many previous work addressed egocentric action recognition as a standard classification task, where train and test data follow the same distribution. Whereas in this work, we address generalization tasks that includes evaluation not only on shared distribution with training data, but also in novel environments, objects, and actions that have not been seen during the training. To generalize beyond given set of classes, it's natural to use large-scale multimodal pre-trained models such as CLIP. To give context to the contribution of our paper, I'll briefly describe components of CLIP zero-shot classification. First, text-based linear classifier is formed from the frozen text embedding of the respective text labels. Then, video representation vector is an average of the subsampled frames in the joint text visual embedding. To classify this video, dot product between video representation vector and text-based linear classifier is used. As I mentioned earlier, if we classify egocentric videos in such a way, we obtain only about 10% accuracy, while full fine-tuning will lead to the loss of generalization to unseen classes. Therefore, we propose to adapt the zero-shot classification of clip-like models to egocentric domain. To this end, we introduce adapter module that allows us to adapt text-based linear classifier to each input video independently. Having a closer look at the architecture, the video representation vector is adapted and then added to the frozen classifier, namely conditioning this classifier on the input video. It is simple as that. To classify the input video, we apply dot product between the original frozen video representation and the adapted classifier. As an illustration, on the left, original clip model classifies the video as painting. It is the main visible object in the scene. Whereas on the right, textual representations are shifted and videos classified as brush, as the person holds brush. So with our method, there is no changes to frozen pre-trained model to keep original generalization. And we adapt the text-based classifier to each instance individually by conditioning the classifier on the input video. In our adapter, we put specific focus on egocentric arrays by attending array around hands to global spatial context, which is followed by temporal attention. In this way, both egocentric and temporal information is encoded only in text representations during classification. To attest flexibility of our method, we also propose to use any pre-trained visual encoder, for example Dino, that might have complementary information to clip-like model for the adaptation of the classifier. Now let's discuss the main results of our method. This table is divided in two parts, whereas on the left is the accuracy on nouns and on the right is the accuracy on verbs. Columns refer to the performance on the corresponding datasets, Ego4D and Epic Kitchens. Note that our adapter is trained on Ego4D for this table. Highlighted zero-shot clip performance is very poor and leaves a great room for the improvement. First, image-based baselines. Note that highlighted accuracy is within distribution evaluation. As expected, nouns classification score significantly higher than verbs. Then baselines that include temporal attention. Clearly, the main gain is visible on verb classification, whereas generalization to other datasets remains behind, especially on the nouns, due to the refitting to the domain. Our method shows significantly improved performance on both within and cross-dataset evaluation. You can find detailed cross-dataset evaluation and more ablations in our paper. To conclude, we propose a new task of egocentric generalization reflecting real-world applications. We propose simple yet effective framework that disentangles temporal information and adapts classifier to each input video. Further, we propose Ego Spatial Temporal Adapter to combine global and local spatial information. and provide extensive experimental results which highlight insights and confirm effectiveness. Thank you for your attention.